Record. Okay, today we're going to be talking about titration curves. It's another diagram that could be expected to draw. For the most purpose, these are just rough sketches. And what you'll have to do more often is interpret them, not draw them. But I have seen a couple times where you've had to actually draw. Okay, so what we're going to be doing, draw and interpret titration curves qualitatively, meaning not precisely, but quantitatively as well for reactions involving strong acid with strong base, strong acid with weak base, strong base with weak acid. Select based on the nature of the species involved an appropriate indicator for an acid-base titration, and determine qualitatively the nature of the equilibrium at the stoichiometric equivalence point. Strong acid is mixed with strong base, or strong base is mixed with weak acid. So we'll be able to look at a titration curve, figure out what's happening. So what is a titration curve? First of all, remember, these are some important points. The equivalence point, so write this down. The equivalence point of a titration is the point at which the amount of titrant, remember the titrant is what's in your burette, the amount of titrant added is just enough to neutralize the sample. Just enough. The equivalence point, so the moles of acid is equal to the moles of the base. Okay, just a note, the equivalence point is not the same as the end point. What is the end point? That's where it turns color. And we're going to learn today the significance of the two, where the indicator turns color. Significant is that you pick your indicator so that it changes at your equivalence point. Okay, that is the significance of why you use certain indicators for certain times. And we're going to learn how we can choose that. So what is a titration curve? It's another way to determine the equivalence point quickly without having to do as much calculation. But it is a plot of the pH of the sample versus the volume of titrant added during a titration. Plot of the pH of a sample versus the volume of titrant added. Record. So this is what a titration curve looks like. This is what they got. Okay, during a titration, they had a pH meter in the sample. Okay, so as they added some of the titrant, they recorded the pH. So the initial pH was 0. What does that mean? What's your sample? If the initial pH before you added any titrant, pH was 1. Acidic. pH of 1 means it's an acid. When you added 10 milliliters, pH went up to 1.37. So if the pH is going up, what are you adding? Base. You're adding a base. So it starts at 1, it's getting more and more basic. Notice that when it gets up to here, what do you notice about the pH? It's a big, big jump. And that's why I said when you were doing the titration, at first it seemed like it took forever to get any change at all. Then all of a sudden it went instantly pink. That's because the pH changes very, very rapidly around the equivalence point. Okay, so that's what's happening here. Then after this point, you've overshot, and your pH continues to go up. So, a couple points of significance. The initial pH tells you whether the sample is an acid or base. So this is how you interpret your curve. The initial pH tells you whether the sample is an acid or a base. The midpoint of the abrupt change in pH marks the equivalence point. The midpoint of the abrupt change in pH marks the equivalence point. And we're going to learn what some of these equivalence points are. If it's a strong acid reacting with a strong base, what is the product you're producing? strong acid, so hydronium reacts with a strong base, which is hydroxide, what do you get? And you can't talk about it at the same time. Okay, so when a strong acid reacts with the strong base, hydronium plus hydroxide, the product is water. So it makes sense that the pH is going to be 7 because you have no other side products being produced. So when a strong acid reacts with a strong base, the pH is 7. So the equivalence point is this point right here, halfway between the abrupt change. So that is your equivalence point. So we can read that at the equivalence point, we needed about 25 milliliters of our base, because we can read down. So at the equivalence point, it's about 25 milliliters, and the pH is 7. Okay, so that's how it works. That's how the connection between the two works. Okay, so another thing that's very significant is if you have a titration curve, this is what it would look like. Now this is a titration curve of a strong base reacting with a strong acid. How do I know it's a strong base with? pH is 13. You're starting at a very high pH. You're ending at a very, very low pH. Okay, so that's kind of the terminology that you got to get used to. If it's a strong base titrated with a strong acid, whatever you start with is how you read it, then what you're titrating it with goes down. So what's the pH here going to be? At the equivalence point, what's the pH? 7. Still, strong acid, whenever a strong acid reacts with a strong base, equivalence point is 7. Now notice that they have 3 indicators here, because you always want to pick an indicator that changes color during your endpoint or during your equivalence point. So that can occur because remember that it only takes a drop for this abrupt change in pH to occur. So any indicator that changes within that range is good. So in this case, so we wanted anything that changed between around 9 and 3 or 4. So you look at your indicator table then, and you want to pick an indicator that has an endpoint somewhere between 4 and 9. That's how you would do it. So a multiple choice question on a public exam, often they give you a titration curve. They ask you what an appropriate indicator would be. So you figure out the range of your endpoint, and then you look at your table to pick an indicator. Okay? That's often how that question is added. Okay, this is a titration curve of a weak base titrated with a strong acid. How do I know it was a weak base and not a strong base? How do I know it was a weak base that I started with and not a strong base? Starts at 11. pH, but more significantly, where's the end point here? No, the end point or the equivalence point. Somewhere around 5. Halfway up the steep point. So the pH, the end point, or the equivalence point, is less than 7. So that means you have a weak base reacting with a strong acid. How do I know it was a strong acid though and not a weak acid? Right, it ends around 1. So somewhere, generally how you can kind of tell is that if it's strong, a strong base is around 13. A strong acid, pH is around 1. This is pH 12. Pardon? It exists in theory. I don't think you'd find something that has that low of pH, but in theory, yes, it does exist. Just like there's a pH does exist of like 14. And above 14, actually, but in theory, again. In reality, I don't think you see them very often.